Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two of the solutions from mechanics, and these two solutions belong to paper 9709/45 for the session May June 25. We are going to start with the solution number 2. Let's see what the question number 2 says. It says a machine for driving a nail into a block of wood causes a hammerhead to drop vertically onto the top of the nail. The mass of the hammerhead is 1.5 kg and the mass of the nail is 0.005 kg. The hammerhead hits the nail with speed 32 meter per second and remains in contact with the nail after the impact. Calculate the speed with which the combined hammerhead and nail move immediately after the impact. Give your answer correct to 3 decimal places. So let's see the system. Yes, this is whole of the system. And first of all here, it carries only 2 marks, so it should be one of the simplest of all solutions, but picking up the concept is the major part of the solution. First of all, we should know which concept is applicable in this case. If we analyze the question, we will see that hammerhead is hitting the nail. That means this is collision between two objects. That's why we are going to apply the concept of the momentum, conservation of momentum. So conservation of momentum is mass of particle A or H. We can write hammerhead. Mass of hammerhead into initial velocity of hammerhead plus the other object is mass of nail into initial velocity of nail is equal to, that initial means just before hitting the nail, then mass of particle H, I mean hammerhead, into final velocity of H, and totally it is coalesces. So will after the collision, look at this, after the collision it is written remains in contact with the nail. So both of them have been coalesce. So we can write coalesce, okay, velocity of coalesce plus mass of nail into velocity of coalesce, that means after the collision. Then mass of particle H, I mean hammerhead, is 1.5 kg, 1.5 kg, and it was at rest initially. Sorry, not at rest. It was hitting at a speed of 32 meter per second. 32 meter per second. Then mass of the nail was 1.005 kg, 0.005 kg into the nail was at rest. Look at this. Mm, Nail is definitely at rest. Calculate with the combined hammerhead and nail move immediately after the impact. The hammerhead hits the nail and remains this one. So initially hammerhead was at rest. That's why initial velocity before hitting or before collision, the velocity of nail was 0. Then hammerhead mass of hammerhead is 1.5 kg. So 1.5, and velocity of coalesce or combined object plus mass of nail is 0.005 into velocity of combined object. If we multiply 1.5 by 32, it is going to be 48, equal to, it is 0, then 1.5 plus 0.005. So this is going to 1.505 velocity of the combined object. Then velocity of coalesce or combined object is 48 over 1.505. Hence, velocity of the combined object is, if we divide 48 by 1.505, it is going to be 31.8937. So if we round it up to three significant figures, it is going to be 31.894. 894 is the velocity of the nail after collision. So that is our answer. Now let's move on to the next question, the immediate next question, I mean B. Let me write here answer. And B says, sorry, there is a constant resisting the motion of magnitude 25,000 Newton. Calculate the distance the nail is driven into the wood. So one thing is very sure here, that we will have to find the distance, and for distance simply we apply the concept of the Subert formula. And Subert formula, for any of the Subert formula, we'll have to know the acceleration of the object. So for acceleration we will have to apply the concept of the motion law of Newton. So as nail is being entered, it is downward force, so we will write the concept of the motion law of Newton is driving force minus resistance force is equal to mass into acceleration. Well, we are searching for acceleration because without acceleration we cannot apply the concept of distance. Well, so or driving force. We know that a driving force is mg cosine, we can write sine 90 degree, because the hammerhead is hitting the nail vertically downward, minus resistance to motion is to be obtained. Okay, it is given, sorry, resistance to motion is 25,000, 25,000, and mass of both of the particles combinedly is 1.505 into acceleration. Okay, then our acceleration is going to be, okay, mass of both of the particles combinedly, it is 1.505 into acceleration due to gravity is 10 and sin 90 is 1, minus 2500 is equal to 1 point, we can write 1.505 equal to acceleration. So our acceleration is going to be, if we do this calculation using our calculator, let me do the calculation. Using our calculator, we get the acceleration is equal to negative, it must be negative, negative 16601, 16601 point 29568, 29568 meter per 568 meter per second square. This is our acceleration. I have taken more digits than necessary so that we get more accurate answer. So they have told us to find distance, so we should not forget that distance is equal to v square is equal to u square plus 2as. Okay, so let us write our concept for finding, because another formula is s equal to ut plus half at square. That means time is to be known, as we don't know the value of t, so simply we are going to apply the formula of v square is equal to v square is equal to u square plus 2as. So v square is the final velocity of the object. It must be zero, because when the nail was hit by the hammerhead, finally they came to rest. That's why final velocity is zero. Initial velocity was 31.894 square. From the previous question, we can use this. Let us see. How much was it? 30. This is our initial velocity while it hit, then it is going to be 31.894, 31.894 square, plus as acceleration is negative, so it is going to be 2 into acceleration is 16601.2956 into s. Okay, into s, and s is equal to, we require s is equal to if we transpose this 31 to the other side, it is negative, so both of them are going to be positive. 31.894 square is equal to 2, sorry, not minus, there will be no negative symbol. 2 into 16601.295. Then let's use our calculator. Equal to, let us use our calculator. The calculator shows that 31.8 and 4 square divided by 2 into 0.0306 meters. So this is what our final answer to the second part of the same question is. So it was very simple to find. In the first case, actually, you may get confused with uh, application of concept. Simply, you just think that there are two objects, one is hitting the other one, that's why it is collision. So we'll have to find the velocity before the collision and after the collision, for which we always apply the concept of the conservation of momentum. Then in the second case, they have told us to find distance or speed, distance. For distance, we apply the concept of the Schubert formula. For Schubert formula, any of the Schubert formulae, acceleration is to be known, and acceleration can be obtained from the concept of the motion law of Newton. Then we have obtained this as acceleration. This is our acceleration. Using this acceleration, we have got that the nail got 0.0306 meter into the wood after hitting by the hammerhead. Well, let's move back to question number 1. Question number 1 says, a box of mass 25 kg is pulled 12 meter up a rough plane inclined at an angle of 8 degree to the horizontal. The box moves up a line of greatest slope against a frictional force of 50 Newton. The force pulling the box is parallel to the line of greatest slope. The box starts from rest and has speed 2.4 meter per second at the end of the 12 meter. Find the work done by the pulling force. So here, first of all, we can easily pick up the concept. They have already written the concept is work done by the pulling force. So work energy equation is to be applied as they have suggested indirectly to apply. So, and in work energy equation, the components are initial and final velocity of height, I mean difference between the initial and final velocity of height, and initial and final value of height, and initial and final velocity of the particle. So let us see what is the scenario. The scenario is this. Okay, angle is 8 degree. It is 8 degree, and the particle was moving up, and it moved to 12 meters. So hypotenuse is 12, and this is our h, angle is 8 degrees. So our h is equal to what? H is equal to, we know, hypotenuse and sine 8 degrees. Sine 8 degree. Sine 8 degree. Well, we have already decided that we are going to apply the concept of the work energy equation. So work done by driving force minus work done by resistance force is equal to change in GPE plus change in KE. That means change of gravitational potential energy as well as change in kinetic energy. Well, so work done by driving force is to be obtained. So work done by driving force will remain as it is. And resistance force, work done by resistance force. We know work done by resistance force is F into S. F is equal to what? Let us see the frictional force. That means external force in this case is 50, and the displacement it made is 12 meter. Okay, so it's 12 equal to change in GPE is mgh, plus kinetic energy is half of mv squared. Okay, work done by driving force is, remember, you may get confused with the resistance to motion. In resistance to motion, you may tell that why are we ignoring weight. Remember, in work energy equation, external force is not only external force is applied, calculated. No internal force is applicable, as there is no external force acting on this, so there should be no resistance to motion due to weight. Weight is not calculated in work energy equation. Okay, external force is only driving force, pulling force. Okay, and there is no other force acting on this. Well, so it is 600 equal to mass of the particle was 25 kg, box was 25, into acceleration due to gravity is 10, and height we have already found. Height is 2 sine 8. 2, sorry, 12, not 2, it is 12 actually. 12, so 12 sine 8, 12 sine 8, that means initially the this was the horizontal line. Initially height was 0, then finally height was h, and h is equal to 12 sine 8 degree, plus if we use half mv square, so half plus half, mass of the box is 25, and initial velocity was, it is given here, 24 meter per second. If we see here, we will see that 2.4 meter per second. So 2.4 meter per second square. 2.4 square. So this is actually difference between the initial and final velocity. Initial velocity was 0 because it started from rest. That's why final velocity minus initial velocity is 2.4. Then let us do the calculation. Work done by driving force is equal to 60, plus it is going to be 250 into 12, that is 3000. 3000 sine 8, plus it is going to be 12.5 into 2.4 square. Hence our work done by driving force is going to be, let us use our calculator, 60 plus, not 60, it is actually 600. So 600 plus 3000 sine 8 plus 12.5 into 2.4 square is equal to, let us see the calculator, it is 1089.51. 1089 1089.52. If we round it up to three significant figures, it is going to be 1090 joule. So this is what the answer to the question number 1. So that's all about the both of the solutions. Let me show the solution to two parts of the solution number 2. This is what the solution number 2, whole of the solution, and for solution 1, this is whole of the solution. And thank you all for being with me, and may Allah bless us all with all beneficial knowledges. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics, and these two particular questions belong to paper 9709/45 for the session May June 25. Let's start with the question number 3. It says, a train travels 4.8 kilometer between two stations A and B. The train starts from rest at A and accelerates at a constant rate until it reaches a speed of 30 meter per second. It then travels at this constant speed for t seconds before decelerating at a constant rate, coming to rest at B. The total time for the journey is 180 seconds. Find the value of t and hence find the distance moved by the train while traveling at the constant speed of 30 meter per second. Well, it's a very easy and simple question. We don't have any difficulty to solve this. So before solving the question, before finding the total distance, we are going to draw a velocity time graph. If we can easily draw the velocity time graph, then solution becomes much easier. So let us draw the velocity time graph. This is the velocity, that means vertical axis velocity. After that, this is velocity, and we are supposing this horizontal axis as time, t second, and vertical axis is v meter per second, v meter per second. Okay, let me write this s over here. Okay. Sorry. Then it started from the first station, means A, from rest. And first phase, there are three phases. In the first phase, the acceleration was constant. So this is the acceleration for the first phase. Then the train was traveling at a constant speed. That means just parallel to the horizontal line. After that, it reaches the, look at this, coming to rest at B. At B, it was at rest and it was moving at a constant rate of deceleration. So, which one is our T? Actually, they have told us to find constant. Look at this. It first up to 30 meter per second. So, here it is 30. Let us write here 30. Okay. So velocity is 30 when it was accelerating at a constant rate. Then this is our t. That is the time when the train was traveling or moving at a constant speed. And the total time taken by the journey is 180 seconds. This is 180. Okay. Now, first of all, we should know that what is this T standing for. Well, so we know. Let me erase this portion which is unnecessary because there is no negative velocity. Well, so total distance. We have a clue that total distance S is equal to total distance. Can I use a different ink? So total distance is given total distance. How much is the total distance given? Total distance is given, look at this, 4.8 kilometer. That means 4800 meters. Well, and we know total distance is equal to what? The area traveled by the train. That means this whole of this area is area of this trapezium shape. This is starting from 0 until 180. So it is a trapezium, and what is the formula for a trapezium? We know the formula for a trapezium is half of, let us write, half of the sum of the parallel sides. From here until this one is one of the parallel sides, which is t, length of which is t, and the other parallel sides is this, which is 180. So t plus 180 is the sum of the parallel sides into the height. How much is the height? This is height. Okay, this is the height between the parallel lines. Okay, so how much is the height? Height is 30 meters, means velocity was 30, maximum velocity was 30 meter per second, then equal to 4800. Well, now if we dissolve 30 by half, it is going to be 15. So 15 into t plus 180. T plus 180 is equal to 4800. After that, if we divide 4800 by 15, it is going to be t plus 180 on the left side, and it is going to be 15 3. Okay, 15 threes are 45, so 30 15 2, that means 320. It is 320. Hence our t is going to be, t is equal to, from 320 if we subtract 180, it is going to be 140. So the value of t is 140. That means the train was traveling at a constant speed for 140 seconds. So this is one of the answers we can show. Okay, then the next part is they have told and find the distance traveled by the train while traveling at the constant speed. That means we will have to find the distance between these two straight lines. That means this distance is to be, this area is to be found. Okay, so for distance we know a formula, Shubert formula. What is the formula? I think you remember that formula is S equal to ut plus half at square. Okay, so distance S is equal to, we can write here, distance, no, not with this ink, let me change the ink. So distance S is equal to distance S equal to, sorry, distance S equal to, ut plus half at square. Okay, now our u initial velocity, look at this. If we talk about this place, this portion, for this portion initial velocity was what? Surely 30. So 30, and time. How long was the time? We have already obtained that the time is 140 seconds. Okay, so into 140 plus half of acceleration. Look at this, as the train was at this phase, look at this, at the second phase there are total three phases. The first, in the first phase, the train was accelerating, raising its speed until 30 meter per second. Then it was moving at a constant speed. So when there is a constant speed, then there is no acceleration at all. So it is going to be 0. Well, now it is not 40, it is 140. Sorry, it is 140. So finally we are going to get 3 14s are 42, isn't it? 42 and 2 zeros. So that is what the total distance, when the distance traveled by the train when it was moving at a constant speed of 30 meter per second. So this is the second or final answer to this question, and I think you have understood this very easily because there is no twist or complication in this question. So let's move on to the next question. And here, please don't get confused with this, that distance is equal to ut plus half at square. Here actually it is about the time when it was traveling at a constant speed. That means already we have found the time length of the time it was moving at a constant speed was 140 seconds. So we have applied simple Schubert formula, S equal to ut plus half at square, and as it is moving at a constant speed, there should be no acceleration at all, so a is 0. That's why it is simply S equal to u into t, which is 30 into 1. 30 is initial velocity, final velocity is also 30, then into time is 140. That means 4200 meters have been traveled by the train. Let's move on to the question number 4. The next question is on the next page. So this question says, well, coplanar forces of magnitude 17 Newton, 51 Newton and 34 Newton act at a point O in the directions shown in the diagram, where tan alpha is equal to 15 over 8. Find the magnitude and direction of the resultant of the three forces. It carries 6 marks, so it should be a little bit longer. So first of all, before moving on to the solution, let us complete the diagram. Okay, if we complete the diagram, it will look like this. This is horizontal axis, this is horizontal axis. Okay, then this is the triangle, one triangle, this is one triangle, and that is another triangle. After that, this one is the third triangle. So as there are three resultant three forces acting on the particle, so there will be three forces. Let us erase these unnecessary parts. Well, we have already completed the diagram. Then there is one more information given here, which is tan alpha is 15 over 8. So if it is a triangle, angle is alpha, this is alpha, and tan alpha is, we know, opponent over adjacent. Opponent is 15 and adjacent is 8. Now we require hypotenuse. How can we find hypotenuse? We know that hypotenuse is equal to, hypotenuse is equal to what? Square root over opponent square plus opponent square plus adjacent square. Adjacent is 8 square. So 15 square means 225 plus 64, 279, I mean 289. So 289 is the square root of 289 is 17. So our hypotenuse is 17. This is 17. Well, so our sine alpha is going to be sine alpha, because if we resolve the forces vertically and horizontally, we must use sine and cosine alpha. Sine alpha is equal to what? Sine is opponent over hypotenuse. So 15 over 15 over, let me erase this. Okay, 15 over hypotenuse is 17. Then cos alpha is equal to, cos alpha is going to be adjacent over hypotenuse. Hypotenuse is 17, so adjacent is 8. 8 over 17. Okay, we have got both the sine and cosine values. Now we will have to resolve the forces. First, let us resolve the forces horizontally. So resolving forces horizontally. If we resolve the forces horizontally, then let us write. How will we write? We will write first. Yes, this can be shown. Let me show a little more. Well, so it is horizontal direction can be shown here. So x is equal to resultant force in x direction. So for the first triangle, it is 51 cosine alpha. For horizontal force, we use cosine angle, cosine alpha. Then plus the second triangle. For second triangle, it is 34 cosine alpha. 34 cosine alpha. Then this is our center. Okay, so from this center, as this is negative direction, this is negative direction, so we will have to subtract this. If we subtract, it is going to be 17 is the magnitude 17. Now we will have to find this angle. How much is this angle? Total is, look at this, total is 180. We are talking about only this portion. So this angle is going to be from 180, the middle portion is 90. So 90 goes away and alpha goes away. So this is 90, 17 cos angle is 90 minus alpha. That means 180 minus 90 minus alpha. So it is 90 minus alpha. Well, after that, equal to, now we are going to substitute the values. Already we have obtained cos alpha is 8 over 17. 8 over, I think before writing this we will have to expand one more line, because you are going to know why I am not applying the values over here. 51 plus 34, it is 85. 85 cos alpha minus, now look at this, cos 90 minus alpha is actually sine alpha. You know, this is not a new topic to be learned. In this case, we know that cosine 90 minus alpha is sine alpha, angle of sine. So it is going to be 17 sine alpha, 17 sine alpha. Now we can easily apply the values. Let us do so. Or 85 into cos alpha is equal to, we have obtained 15 over 17. 15 over 17 minus 17 into sine alpha is 8 over 17. 8 over 17. So finally our resultant force in x direction is what? It is going to be 17, 5, 5, 15, 75. And from 75, if we subtract this, sorry, we made a mistake. Cos alpha is not 15 over 17. Cos alpha is 8 over 17. So it is going to be 8 actually, and it is going to be 15. So 8 over 17 and 15 over 17. So what is it going to be? 17 5s are 85, 5 8s are 40. So 40 minus 15 is 25 Newton. So horizontal force, resultant force is 25 Newton. Well, now we are going to resolve the forces vertically. So let us write resolving forces vertically. Resolving forces vertically. Resolving forces vertically. So our direction is vertical direction, and it is termed as y. So y is equal to, let us see, using the same concept we are going to write them. Okay, y is equal to, for the first upper triangle, it is 51 sine alpha. Then there is no more force vertically upward. Look at this, only there is one force which is acting vertically upwards. Rest of the forces are acting downward. So there will be subtraction minus. For the second triangle, it is 34 sine alpha minus 34 sine alpha, magnitude was 34. Then another one is also lying from the reference frame, it is also below this, so this is negative. Then 17 sine alpha, 17, it is not sine alpha as I have told earlier, it is, look at this, if we talk about this third one, this triangle, in this triangle, the third one here, it is not alpha, it is actually, total is 180, from 180 middle portion is 90, so 90 minus alpha, that is 180 minus 90 minus alpha, that is 90 minus alpha. So it is going to be 90 minus alpha, as we used in the previous case also. So 90 minus alpha. Okay. After that, we are going to substitute the values, or let us expand this. So 51 minus 34, that is, from 51 if we subtract 34, that is 17. 17 sine alpha, 17 sine alpha. And sorry, here I forgot to write 17 sine. So let me use the eraser. Erasing this, let me write here 17. It is 17 sine actually, because we are resolving the forces vertically. So it is 17 sine 90 minus alpha. So 90 sine 90 minus alpha is cos, well. So that is minus 17 minus 17 cos alpha. Now we are going to substitute the values. It is 17, and sine alpha we have got, it is 15 over 17. 15 over 17 minus 17 into cos alpha is 8 over 17. 8 over 17. So finally our resultant force is what? Our resultant force is going to be 7. So 15 minus 8, that is 7 Newton. It is 7 Newton. So the horizontal resultant force is 25 Newton and vertical resultant force is 7 Newton. Now we are going back towards our question. They told us to find what? They have told us to find the magnitude. So the magnitude is, if we draw a diagram like this, let me show. So this is our figure. In the x direction, this is x direction and it is y direction. Okay, so in the x both of them are positive. Look at this here. In the x direction, the resultant force is 25, which is positive, and in the y direction also resultant force is 7, which is positive. So as both of them are positive, the magnitude will fall in the first quadrant. Okay, so this is our triangle. Let me draw the triangle a little better. Let me erase this. Okay. Then this is our triangle. This is our triangle. Okay. Now this is angle, and our vertical resultant force is how much? Vertically we have got 7 Newton, and horizontally we have got, if this is 0, so horizontally we have got how much? 25. This is 25. Now we will have to find the magnitude. Hence magnitude is equal to, we know magnitude means the length of this hypotenuse. Okay, this is magnitude. This is the magnitude. Okay, This is magnitude. Okay, so magnitude means in terms of triangle, this is hypotenuse. How can we find hypotenuse? So let us write here. I will use the left side for writing. So magnitude is equal to magnitude is equal to, how can we find this magnitude? That means this hypotenuse is equal to square root over uh, horizontal length, that is 25 square plus 7 square. So let us use our calculator for finding this. 25 square plus 7 square means square root over 625. Let us use our calculator. Okay. Square root over 625. 625 right. 25.96 means 26. It is actually 26 Newton. 26 Newton if we round it up to three significant figures. So 26 Newton is the resultant force of this system. Well, now not only magnitude, they have told us to find the direction. They have told us to find even the direction. Look at this here. It is written and direction. Okay, so direction is already we have found here. Okay, this is the direction, means it is lying above positive x-axis. But how much is this angle? We'll have to know angle. So easily, as we know opposite side as well as adjacent side, we can easily apply the tan formula. So tan inverse of, and tan inverse of theta is equal to, we can write theta is equal to, sorry, let us write our angle direction. Okay, angle theta is equal to tan inverse of what? Tan inverse of 7 over 25. 7 over 25. Tan inverse of 7 over 25. 7 over 25. Then we will find the value of this using our calculator. So theta, hence theta is going to be, tan inverse of, let us use our calculator. Tan inverse of 7 over 25. Tan inverse of three significant figures, it is 15.6 degree. 15.6 degree. 15.6 degree. Now how to write this? We got that magnitude is 26 Newton, magnitude 26 Newton, and angle is 15.6. Where is the angle lying? Angle is lying at this point. Look, it's in the first quadrant. So how to write this? Let me change the ink to write this. We can write here for the final answer direction. For direction, if I use this tiny space, okay, direction, then you will write here direction. Direction is 15.6 degree. 15.6 degree above positive positive x-axis, positive x-axis, because I have already shown you that the magnitude, I mean the magnitude of the force is lying on the first quadrant, so it is above, as angle is positive 15.6, so it is lying above positive x-axis. So that's all about the solution to the question number 4. it is actually A, still B is left. So A is, what did we do? Once again, I'm just telling it in brief, that first we have resolved all of the forces horizontally, then we have got 25 Newton, then we have resolved all the forces vertically, then we have got 7 Newton. Then after this we have found, after 7 and this 25 Newton, we have just found magnitude, and magnitude is that hypotenuse of the triangle, and both x and y are lying, both x and y are positive, so they are, the magnitude will lie in the first quadrant. So magnitude is actually the length of that line, this hypotenuse, and the length of hypotenuse is the square root of horizontal, I mean adjacent square plus opposite square, and total we have got finally 26 Newton is the magnitude. And direction is, we know both vertical and horizontal length, so easily we can apply the tan formula. So theta is equal to tan inverse of 7 over 25, then we got theta is equal to 15.6 degree, and definitely it is lying, the angle is lying above the positive x-axis, means first quadrant. Well, let's see the second question. The next question is, on the next page. Okay, it says the forces of magnitude 51 Newton is replaced by a force of magnitude P Newton acting in the same directions. The resultant of the three forces now acts in the positive x direction. Look, here there is a twist actually. It says that all three forces are acting in the positive x direction. That means in y direction there is no resultant force. So we will use that concept that vertically there is no resultant force. Okay, so if we resolve the forces vertically, then we can write vertical forces. For vertically, what was our equation? We can just copy this from here. Look at this, vertical direction was what? 51 sine alpha. Instead of 51, just here we will use, instead of 51 we will use P, and rest of them will be unchanged. So y direction 51 sine alpha, P sine alpha minus 34 sine alpha. Okay, let us write P sine alpha, P sine alpha, let me change the color, P sine alpha minus 34 sine alpha, 34 sine alpha, rest of the part will remain unchanged except 51. 51 has been replaced by P sine alpha, then minus 17. Let us see what was it. Minus 17 sine 90 minus alpha. 17 sine, yes, 17 sine 90 minus alpha, and we know that 90 sine 90 minus alpha is actually cos alpha, or P of sine alpha, and we have already applied the value of sine alpha. Let us see for the last time. The sine alpha was not over here, over here. Sine alpha was this, sine alpha was what, 15 over 17, and cos alpha was 18 over 17. Okay, so we are going to apply this. Sine alpha is 15 over 17. 15 over 17. Yes, this is 15 over 17 minus 34 sine alpha is 15 over 17, same 17, and 17 into sine 90 minus alpha is actually cos alpha, and cos alpha is 8 over 17. 8 over 17. And we forgot to use the equal symbol because vertically, once again I am clarifying this. Look, this is the twist of this question. They told that horizontally there is the resultant force, whereas vertically or in y direction there is no resultant force, so it is actually zero. Resultant force is zero, there is no resultant force, that means it is balanced. So vertically there is no resultant force, but there is a resultant force in x direction. I mean horizontally there is resultant force, but vertically there is no resultant force, that's why it is actually zero. So what is it going to be? 50p into 15 over 17, 15 over 17, and in the right side it is going to be 215, so 30, 30 plus 8, so 38. It is going to be 38, or p is equal to 38 into 17 over 15. Hence our p is going to be, if we multiply 38 by 17 and divide it by 15, our p is going to be, using our calculator, 38 into 17 over 15, that is 43.06. So if we round it up to three significant figures, it is going to be 1, and that is what our p, the value of p is 43.1. So that's all about the whole of the solution. Let us see the first part of this question. Actually, in the first part, we have found the resultant force, which was 26 Newton. And if in one sentence I clarify this, first we have found the resultant force in x direction, then resultant force in y direction. After that, we found magnitude. Magnitude is square of both of the sum of the square of the both of the forces. Then the angle is actually, we have applied, we have already got both x and y values or length of the horizontal and vertical axis, so we can easily apply the formula of tan inverse of 7 over 25. It is 15.6 degrees. So angle is 15.6 degree, and since both angle is positive and both x and y components are also positive, so it is lying above positive x-axis. So that's all about the solutions. This is number 3. Then first part of 4. After that, final part of 4. In 4, actually in B there is only one twist. They have written there is a resultant force in the x direction, that means in y direction there is no resultant force. That's why we have used equilibrium formula, that resultant force is equal to 0, and finally we have obtained that p is equal to 43.1. That's all about this solution. We have, actually this is very important. All the concepts are very important in mechanics. I believe that you have understood my clarification and explanation. Thank you all for being with me, and may Allah bless all of us with beneficial knowledge. Fi amanillah. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this question belongs to paper 9709/45 for the session May June 25. Let's solve question number 5, which says a car of mass 1500 kg is traveling along a straight horizontal road. It is given that there is a constant resistance to motion. the engine of the car is working at 24 kilowatt while the car is traveling at a constant speed of 32 meter per second. The power is now increased to 28 kilowatt. For the acceleration of the find the acceleration of the car at the instant it is traveling at a speed of 36 meter per second. So the question is not difficult at all. First of all, we should know there are two information. One is there is a constant resistance to motion. First of all, we will have to find what is or how much is the resistance to motion, and we are going to apply the concept of the motion law of Newton. Let's start our writing as it is moving along horizontal road. So this is the direction, and our concept is driving force minus resistance force is equal to mass into acceleration. Well, so driving force is, we know driving force means power over velocity, minus resistance is constant, so it will remain unchanged. And we are not ignoring the weight also, because sometimes students ask that why are we ignoring the resistance, I mean resistance caused due to weight. Actually we don't ignore. Let's see what is it, mg sine 0 degree, because this is exactly along the horizontal road. Mg sine 0 degree is equal to mass into acceleration. Look, as it is traveling at a constant speed, so there is no acceleration at all. Well, and our power given is, what is the power given first, 24 kilowatt. So let us write 24 kilowatt over velocity. Velocity was 32. 24 kilowatt means 24,000 minus our resistance to motion, and sine 0 is 0, that's why it is 0. Hence our resistance to motion, if we divide 24,000 by 32, it is going to be 750 newton. So 750 newton is our constant resistance to motion. Then they have told us to find the acceleration. Now we are going to find acceleration. Let us write again. Again, again, the same concept, and it is moving horizontally forward. Driving force minus resistance to motion is equal to mass into acceleration. Well, or driving force is the same concept, power over velocity minus resistance to motion has already been found. We have already got that resistance to motion is constant, which is 750 newton, 750. And we are not ignoring weight also, mg sine 0 degree is equal to mass of the car was 1500 kg. Yes, it is 1500 kg. So 1500 accelerate, 1500 into acceleration. Now we are going to substitute the values. Let us see power is now how much. Power is now 28 kilowatt. So 28,000 over velocity is 36. Velocity is 36. So it is going to be 28,000 over, or 28,000 velocity is given 36 minus 750 is equal to, sine 0 is 0, so there is no necessity of writing this, 1500 into acceleration. if we divide 28,000 by 36, let's not divide this. Let us simplify. It is going to be 36 is the denominator. If we multiply both of the quantity by 36, it is going to be 28,000 minus 750 into 36 is 27,000. 27,000 equal to 1500, or 15 can be transposed to the other side, equal to A. Or A is going to be, if we dissolve the two zeros from every side, from every quantity, it is going to be 280 minus 270 means it is 10. So 10 over 36 into 15. If we multiply 36 by 15, it is going to be 540. 540. 500 as well as 40. 500, I mean 540. Hence, if we divide 1 by 54, it is going to be, let us do the division. 1 divided by 54. 1 divided by 50 significant figures, it is going to be 0.185. 185 meter per second square. So that's all about the solution to this part of the question. They have told us to find acceleration, but as the resistance to motion was constant and it was missing, that's why first of all we have found the quantity or amount of resistance to motion. Let's move on to the immediate next question. The next question says, it is given instead that the resistance to motion of the car is 340 plus 4 V Newton when the speed of the car is V meter per second. When the engine is working at 20 kilowatt, the car is traveling at a constant speed. So we are going to find the constant speed. We are going to apply the same concept, and the direction of the car is still same. That means horizontal, straight to the horizon. Then our concept is driving force minus resistance force is equal to mass into acceleration. So driving force is again the same formula, power over velocity minus resistance to motion is given as 340 plus 4b. Instead of plus, let us write minus 4b. And you know the resistance due to weight is mg sine 0 degree, sine 0 degree. And as the car is traveling at a constant speed, there is no acceleration, means it is 0. So power given is, power is 20,000. So let us write 20,000 over velocity is to be obtained, and this is 340 minus 4v is equal to 0. If we multiply every quantity by v, it is going to be negative 4b square. If we, okay, negative 4v square minus 340v plus 20,000. If we multiply every quantity by v equal to 0. If we divide every quantity by negative 4, it is v square minus 8 for 32, so it is 85. 85 into v, and it is going to be not minus, it is plus, this is minus It is 4 5s are 20. So it is 5000 is equal to 0. Now if we expand this, then v square is equal to v square plus 125 minus 40v minus 5000 is equal to 0. If we simplify more, I mean if we factorize, it is going to be v plus 125, then v minus, here 40 is common, so 40 is equal to 0. Hence our velocity is equal to 40 meter per second. Now you may ask a question, why are we avoiding these information, I mean first factor? Because we can write here, since it is speed, constant speed, so speed can never be negative since v is greater than 0. Okay, the speed was positive, actually speed is never negative, so our velocity is more than 0, hence we have chosen the positive value of v. And that's all about the solution to this question, and I believe that you have understood it well. Let me show the previous page again. Here 0.18, no, 0.0, sorry, I made one mistake over here. It is 0.0, 0.0. So let us write 0.0185 up to three significant figures. So these are the solution to the different parts of this question, which is very easy and simple. You can do it yourself even. So thank you all for being with me. Fi amanillah. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/45 for the session May June 25. Let's see what the question number 6 says. A particle P moves in a straight line starting from a point O. At time t second after leaving O, the velocity v meter per second of P is given by v is equal to 15 minus 2t whole squared. Find the values of t when the velocity of P is 100 meter per second. So it's one of the simplest and easiest of all questions. Let's start the solution. The expression of v is v is equal to 15 minus 2t whole squared. Then they have told us to find when velocity is 100. So we can write 15 minus 2t whole squared is equal to 100. If we transpose the square to the other side, it is going to be square root over 100, means positive negative 10. Okay, or minus 2t is equal to negative 15 plus minus 10, or if we discard this negative symbol from each of the sides, it is going to be, or 2t is equal to 15 plus minus 10. Now look at this. If we use the positive symbol, 15 plus 10 is equal to 25. If we divide 25 by 2, it is going to be, so our t is going to be 25 divided by 2, so 12.5. Let us take the smaller value first. If we subtract 10 from 15, it is going to be 5. If 5 is divided by 2, it is going to be 2.5, or the second value is going to be 12.5 second. So these are the two values of t. Let's see what the next question says. The next question is, show that there is a particular value of t for which the velocity and acceleration of the particle are both 0. So first of all, velocity is 0, v is equal to 0, and we know that v is 15 minus 2t whole squared is equal to 0. That means our 15 minus 2t is equal to 0. Hence our t is going to be 15 over 2 means 7.5. So when at 7.5 second the velocity was 0, then they have told us to find the acceleration at the same time was also 0. So let's find the acceleration. For acceleration we will find the derivative of velocity. So v is what? 15 minus 2t whole squared. Well, if we differentiate both sides, it is going to be dv in terms of t equal to 2. Then if we differentiate the inner part, it is going to be negative 2. So negative 2 into negative 2, then 15 minus 2t, inner function is going to be same, and exponent is going to be 1 instead of 2. After that, so dv over dt, that means derivative of v in terms of t is acceleration. So we are going to find the acceleration. Hence acceleration is equal to negative 4 into 15 minus 2t. Now let's go back to the condition. What was the condition? Condition was that acceleration of the particle are, acceleration and velocity was 0. So a is equal to 0. Let us write. I can write just beside this, drawing a line segment. Yes. So a equal to 0, a equal to 0, when a, we have already obtained our a is negative 4 into, I can show you whole of the part, it is negative 4 into 15 minus 2t. Negative 4 into 15 minus 2t is equal to 0. That means 15 minus 2t is equal to 0. Hence, if we make t as subject, it is going to be 7.5. So what did we get? For both acceleration and velocity 0 at the time when t is equal to 7.5. So they have told us to find the value of t. Hence, t is equal to 7.5 seconds in both cases. Okay. That's all about the answer to this question. Let's move on to the question number C. Question number C is on the next page. Let's see what it is. Question number C says, find the displacement of P from O at the time that the velocity and acceleration of the particle are both 0. So it's all about displacement. Well, for displacement, we know the integrand of velocity is the displacement. Before that, we can draw a graph to understand the scenario. So let me draw the graph over here. Okay, this is velocity and it is time, velocity against time is 0, and our v meter per second is the vertical line. Okay, then Let us see the velocity. Velocity was what? V is equal to 15 minus 2t whole squared, isn't it? Well, let's find the constant value of velocity when t is 0. V is going to be 15 square, means 225. So at the beginning it is 225, 225, 225. Okay. Then as this is quadratic graph, it will move from the second quadrant, and let's see when does it cross the horizontal axis. We have already learned from the previous question. Look at this. When t was 7.5, when t was 7.5, the stationary point, I mean acceleration was 0. At the same time velocity was also 0. So we will have to write that 7.5, 7.5 over here. Let's see, let me write over here, this is 7.5. Suppose here 7.5, 7.5 is over here. Then the curve will look like this way. Okay, let me try to draw one more graph. Yes, it may make sense. So this is our graph. Okay, now we will have to find the displacement. Okay, so v is equal to this. If v is this, then we will integrate both sides. If we integrate from 0 until 7.5 seconds, okay, 0 until 7.5 second, we are going to integrate v in terms of t is equal to, going to be, it will be 1 over 3, because if we integrate, the exponent will increase by 1, so it is 3. And if we differentiate this, it is negative 2, so negative 2. And what will happen to the function? The inner function is going to be 15 minus 2t, and the exponent is going to be 3. Well, so this is our expression, and the limit is from 0 until 7.5 second. Okay, then if we integrate velocity, we know this is nothing but displacement. So let us write displacement means s. S is equal to negative 1. I think this space is not sufficient. Let me say, yes, I can go downward. So it is going to be s is equal to, or s is, s is, s shows the displacement. S is equal to negative 1 over 6, then 15 minus 2t raised to 3, and the limit is from 0 until 7.5. Okay, then let's see whether it will show a positive value or not. If we look at the graph, actually our displacement is this portion. Okay, this portion is our displacement, this portion. This black shaded part is our displacement. Okay, we are going to find the area of this shaded, black shaded dark part. This is our area, and if we notice, we will find that this is above x-axis, so surely it will produce positive value. We are going to obtain a positive value of this area. So let's see what is that area. Okay, then it is going to be, or s is equal to negative 1 over 6, negative 1 over 6, and 15 when it is 7.5. Look at this. When t is equal to 7.5, it is going to be 15. So 15 minus 15 is 0. Then minus, if t is equal to 0, the lower limit, then it is going to be 15 minus 0 means 15. So it is 15 cube. And 15 cube means actually 3375. 3375. Now, if we simplify more, we will get, or s is equal to, and negative negative, it is going to be positive, so it is 3375, 3375 over 6. Let us do the division. After dividing this, our displacement is going to be 6 5 30. So 6 5 again 30. No, 6 6 36. So it is 6, then 15. 15 means 2.5. So this is the distance traveled by the particle starting from 0 until 7.5 second. So this is what the solution to the question of C. And as I have told, it's one of the easiest and simplest of all questions of this paper. So let's go back to the first question. This was the first two solutions, and then in the first two solutions also they are not difficult at all, and so is the third one. And I think you have got my points as I have clarified. It's actually velocity is given, and from velocity if we want to find the displacement, then it's nothing but integration. So we have integrated the velocity expression. And remember, you may ask a question about why isn't there any constant value. Look at this. So if you are confused with this constant value, let's see the graph. When t was 0, look at this. When t was 0 at the time of beginning, there was no displacement at all. I mean, displacement was also 0. Okay, displacement starts from the vertical line to this direction, vertical line to the positive direction of x. Okay, so at the beginning it was on the vertical axis, so there is no uh, displacement at all at the beginning. That's why there should not be any constant value. I think you got my point. So thank you all for being with me, and may Allah bless all of us with the beneficial knowledge that will make the whole humankind knowledgeable, sincere, honest, and devoted to the Almighty Allah. Fi amanillah. Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this question belongs to paper 9709/45 for the session May-June 25. Let's go through the question. Question number 7, which is the last of all questions of this paper. Two particles A and B of masses 6.5 kg and mkg respectively are connected by a light inextensible string that passes over a smooth pulley. The pulley is fixed at the top of a rough slope which is at an angle of alpha to the horizontal ground, where tan alpha is equal to 5 over 12. A is on the rough shape. A is on the rough slope and B hangs below the pulley. See the diagram. The coefficient of friction between the slope and A is 0.4. Given that the system is in equilibrium, find the set of possible values of M. Well, before moving on to the solution, first of all, we will have to pick up the concept. And the concept is, whenever a particle is held equilibrium, we know that there are two possibilities, two cases. What are the cases? One case is the particle is supposed to slide down, the particle is about to move down, or the particle is about to move or slide up. These are the two possible cases. Well, one after the other we will have to analyze both the cases, but before moving on to the solution, first of all we will have to know the components. Well, for the components, let us complete the diagram first of all. So if we complete the diagram, let me zoom it out. Well, then it is going to be, as the plane is rough, first of all we'll have to find normal reaction force. For that, let us complete the diagram. So this is weight, this is weight, not this ink, we will have to use different ink. This is weight, weight will act vertically downward, and this is the normal reaction, normal reaction. Let me erase these unnecessary parts. Well, then this is, so this is a 90 degree, 90 degree, and angle is alpha, our angle is alpha. Well, as the plane is rough, first of all, we'll have to find normal reaction force. So, normal reaction force, there is no upward force acting on particle A. So, it is R plus 0 is equal to now downward force. So, what is the downward force? Downward force is mg cos alpha. And for cos alpha, look, the value of 10 alpha is 10 alpha is given. For from that we will find cos alpha. So let me draw a triangle over here. The triangle is this. This is the right angle triangle where angle is alpha, and they have told 10 alpha is 5 over 12. That means 5 over 12. If vertical line or opposite is 5 and adjacent is 12, so definitely hypotenuse is going to be 13. And 12 square plus, let me show you, it is actually 12 square plus 5 square. So our cos alpha is equal to 13. Okay, so our cos alpha is going to be adjacent over hypotenuse. Hypotenuse is 13, adjacent is 12, so it is going to be 12 over 13. Let us write here, or r is equal to mass of the particle is 6.5, acceleration due to gravity is 10, 6.5 into 10, and cos alpha just we have found, it is 12 over 13. Well, hence our r is, normal reaction is going to be, it is 65, so 5 3s are 65, 5 12s are 60, so it is 60 Newton. 60 Newton is the resistance to motion, I mean normal reaction force. Well, now we are going to apply our concept. As we have already decided, there are two possible cases. One is the particle was about to move down, either about to move down or it was about to slide up. Okay, so let us write one after the other. When we will start writing here, yes, when A is about to slide down. Okay, already I have explained that whenever a system is held equilibrium, there are two cases. One is the particle is about to slide down, or the particle is about to slide up or move up. And we are considering A. Let us discuss B later on. First A. When A is particle A is about to is about to slide down, about to slide down, slide down, slide down. Okay, so let us analyze the scenario. Let's analyze the concept. When the particle is about to slide down, what does happen here? Look at this. When the particle slides down on the rough surface of plane, then what are the forces? Because we are going to apply the um, concept of the motion law of Newton. So let us see which force is causing the particle move down. There is no force except weight. Only weight is causing the particle A move down. So let us write the concept we are going to apply is the motion law of Newton. So when the particle slides down, about to slides down, it is driving force minus resistance force is equal to mass into acceleration. So driving force, as we have already seen, here there is only one force which is causing the particle slide down. What is that? That is weight. Only weight is causing, as weight is acting as driving force. So weight is, we know, mg. Weight is mg. For this one, this is our direction. This is definitely in term of the triangle, it is vertical side or opposite side. So it is mg sine alpha, mg sine alpha. Then rest of the forces, look at this. The particle was about to slide down, and only weight is trying to slide the particle down, but rest of the forces are causing resistance to motion. So what are the rest of the forces? Number one is tension. Look at this, there is a tension in the string. So tension is here negative force or opposite force. Then there is another force which is causing resistance to motion, which is our frictional force. And we know the formula for frictional force is mu r. Mu r equal to mass into acceleration. As the system is in equilibrium, so there is no acceleration at all. Right side is 0. Now let us see how much is sine alpha is equal to. We have written cos alpha is equal to cos alpha. Cos alpha is equal to, we have already written, it's 12 over 13. So surely sine alpha is equal to 5 over 13. Cos alpha was 12 over 13 and sine alpha is 5 over 13. So we are going to just substitute the values. If we apply the values, it will be mass of the particle A is 6.5. Look at this, here it is written 6.5 kg. So 6.5 into acceleration due to gravity is 10 and sine alpha is 5 over 13. We have just written minus tension. Tension can be written on the other side or let it remain unchanged. Minus mu is our frictional coefficient. Our frictional coefficient is 0.4. So it is going to be 0.4 and our normal reaction force, I mean R, already we have obtained the value of R. Our mu is frictional coefficient, which is 0.4. So 0.4 and our R is that is normal reaction force, which is 60 Newton. Okay, so let us substitute as 60. It is 60 equal to 0. Now if we isolate our t will be on the other side. It is 6.5 into 10, 65. If we divide 65 by 13, it is 5. So 25 minus 4 sixes are 24, so it is going to be 24. If we multiply 60 by 0.4, it is 24 and t can be isolated. Hence this can be our equation number 1. Already we have come to know that there are two possibilities of tension. Hence our t is going to be 1 Newton. 1 Newton. Okay, this is one of the possibilities when all the forces are resistance force except weight. Okay, the second possibility. So for the second possibility is, what is the second possibility? We know that this is the tension when the particle was about to move down. Now what is the tension? We will find the tension in the string. Then what is the tension when the particle was about to move up? So let us write it in word. When a particle a, when a is to about to move up, slide up or move up, whatever you write, slide up. Okay, the same concept we are going to apply. It is going to up. So driving force minus resistance force is equal to mass into acceleration, the same concept. Well, now let us see what is the driving force, and we can leave this as equation number 1. This is first tension is equation number 1. Okay, then let's see what is the driving force when the particle moves up. When the particles move up, look at this. Here this is the particle. Okay, it will move up. So when a particle is moved up, there is nothing but the tension is the driving force, and rest other forces are trying to slide it downward. So our driving force is tension, then tension minus tension in this string, that is tension minus, so what are the next forces? First force is frictional force. Frictional force is, we know, mu r minus the other force which is trying to, the other force, this is the particle. Okay, the other force which is trying to slide the particle downward is weight. So weight is mg sine theta, mg sine alpha is equal to mass into acceleration, which is 0 because there is no acceleration at all. Well, then t minus, our mu was zero point 0.4, and we have already used our normal reaction force, which is 60 Newton. So let us write 60.4 into 60. 60 minus mass of particle A is 6.5 into acceleration due to gravity is 10, and sine alpha we have already used. Sine alpha was 5 over 13. So it is 5 over 13. 5 over 13 equal to 0. Hence our tension is going to be, hence let it be the last step for this part. Tension is equal to, it is 24. So 4 6s are 24, 24, and this is also plus, and 65 divided by 13, 5 5 5s are 25, means it is 49 Newton. So there are two cases, two values of tension. Look at this. One is the least value, the other one is the maximum value. Here tension is the external force which is actually holding the particle in equilibrium. Well, now the question is, look, we are not supposed to find the value of tension. They have told us to find the possible values of m. Look at this, we'll have to find the possible values of m. This is our value to be obtained. We are still far away from m. Let's see what is m. M was actually what? The mass of particle b. This is m. Well, then particle B, look at this. So long we have been analyzing the scenario or for different forces of A. Now B. Okay, for B, it's actually very simple. Let me write over here. No, let me write over here on the right side. Okay, so if I draw a line segment over here. Okay, so for A now, when B moves up or down, okay, it's all about B now. When B moves up or down, now you may get confused that why should it be up and down, same scenario. The concept is, suppose we are considering this to be up. Okay, then our concept is driving force minus resistance force is equal to mass into acceleration. Mass into acceleration. Now let's see what is the driving force when the particle B moves up. Look at this particle B. The external force acting on B is nothing but the tension in the string. Only string is acting, and the opposite force is weight. So there are only two forces, and one must be equivalent to the other one. As there are only two forces straight away, that's why whether it moves up or down, it will be actually same. So let's see, if it moves up, then tension is the driving force. Tension is the driving force. So tension minus, what is the force moving it, causing it, resistance or trying to move it down? Nothing but weight. Here only weight is acting downward. So minus weight is mg cos 0 degree. Okay, because it is vertically downward, that is perpendicular through the perpendicular line, that's why angle is 0. Or sine 90, whatever you tell, equal to mass into acceleration is 0. Hence our t, here we can write t equal to mg cos 0 degree. Okay, so this is not the last step. It should be, it should not be the last step, it should be one more step. It is T is equal to, tension in the string is particle B. Look at this, the mass of particle B is m. Here it is uncertain, so if it is m, let us write m into 10. M, that means 10m. Okay, and if we look at this, cos 0 degree is 1, so 10m, 1s are 10m. So tension in the string is 10m. Now let's see whether if the particle moves down, what would happen. Actually they are same as I have shown. Look at this, the upward force is tension, downward force is nothing but weight. So ultimately they are equal to each other. There are no other external force acting on B. That's why whether it moves up or move down, its tension will be same. That means there are only two forces, they are equal to each other. It varies on the basis of the variation of mass. Okay, so tension is equal to 10m. Now if we go back to the equations, look at this. When t is, first t was 1, so we can apply this one. When t was 1, when, or not when, we will write t equal to, t is equal to 1 when m is equal to, look at this, what will be m, mt is 1, so 1 over 10 equal to what, equal to zero point 0.1. And t is equal to, what was the second value we obtained in the tension, second value was 49. When t was 49, t is equal to 49 when m is equal to, same, it is tension is 49, so 49 over 10 means it is 4.9, not there, let me write just below this, it is going to be 4.9. Now let's see what does this mean. There are two values of m, 1.1 and 4.9 kg. Now let us analyze these two values. What does it mean actually? In first case, we have got that the value of m is zero point 0.1. In the second case, we have got the value of m is 4.9. It means actually, if the value is, when did we get zero point 0.1? When tension is 1 unit, 1 Newton. Look at this. That means if the value of, if the value of m, if it is more than zero point 0.1 kg, then the particle would slide down. That means both the particle b would move downwards. If the value is less than zero point 0.1 kg, if less than zero point 0.1 kg, then b would move up. Look at this, if the value of b, once again I'm repeating, if the value of b is more than 1 point, less than, sorry, less than 1.5, then it would move downward. Okay, so, and if the value of b is more than 4.9, the second value is more than 4.9, then the particle would move down. So it's very simple. Once again I'm clarifying, if the value of b is, I mean mass of b is zero point 0.1 less than zero point 0.1, then the particle would move up, b would move up. If the mass of particle b is more than 4.9 kg, then particle b would move down. That means both of the particle slide, b a would slide upward and b would move downward. That's why they have told us to find that, so that the particle, the system is in equilibrium. Look at this equilibrium. As the system is supposed to be equilibrium, the mass of particle b will be in between zero point 0.1 and 4.9. So how should we write the value of this? Then we can write the minimum value should be, minimum value of mass of particle b should be zero point 0.1. Hence let us write the range of the value is going to be from zero point 0.1 until 4.9 kg. If the value, I mean mass of particle b is ranged from zero point 0.1 kg until 4.9 kg, then the system will be in equilibrium. Otherwise, if it is less than zero point 0.1 kg, then the particle A will slide down. If it is more than 4.9 kg, then particle A will slide up, I mean B will come down. So that's all about the solution to this part. Let's move on to the next part. The next part of the solution says, it is on the next page. Yes, it says it is given instead that m is equal to 12 and the particles are released from rest with a string taut. Use an energy method to find the speed of the particles when each particle has moved zero point 0.6 meter. You may assume that this occurs before A reaches the pulley or B reaches the ground. Well, so they have already indicated the concept. Concept is energy equation should be applied. So for energy equation, the components are, we know, height as well as velocity. So initial velocity of both of the particles, they were in rest initially, and final velocity can be obtained. But about height, okay, so we will have to determine the height. They didn't give height, so please don't get confused with this one. This is has moved 6 meters. That means this is their motion movement, but this doesn't mean height. Let's see what is the scenario. For that we will have to, if I erase this, let me zoom it out. This is the figure, okay, and I'm going to erase these unnecessary parts, and or I can show you drawing two different figures. For A, look at this. For A, I mean A was lying on a plane, okay. Suppose this is, here is the particle A is over here, and yes, so this is for particle A, okay. It moved zero point 0.6 meter. Look at this, it is written here how much. 0.6 meter is the length it traveled. So this is our 6 meters. Yes, so for B, this is B, okay, for particle B, for particle B, and angle is alpha, okay. For particle B, it moved up zero point 0.6. This one is 0.6, okay. And now we will have to find, actually we require height, okay. Let me change the ink. As I have told, for energy equation, that one of the components is height, so we require actually height. This is for B, okay. So our height is to be obtained. This is our height. So height is equal to what? We know height is equal to hypotenuse, hypotenuse, then sine alpha. Okay, sine alpha. So height for B, height of B, okay, B is not necessary to be written. So it is zero point 0.6 into sine alpha. From the previous page, we can find our sine alpha was sine alpha. Look at this sine alpha. We have used sine alpha is equal to 5 over 13. So it is 5 over 13. Let us write 5 over 13 here. 5 over 13. So 5 over 13. 5 over 13. So finally, how much is it going to be? It is 0.65, it is 30. I mean 3 over 13 is the height for B. Now for A, height was, it is simple because for A, if we talk about for A, okay, A was, I mean for B, sorry, it was for A. I made a mistake here. It is actually A. It was particle A actually because A was lying on the slope. So it is not B. Let me write over here A. It is A. This is A. And for B, B was actually moving up. Okay. Or down, whatever. It may be up or down. We require to write here. Let's see whether they moved up or down. As mass of particle is 12, in the previous question we have found if it is more than 4.9, then B will move down and A will slide up. As B is more than 4.9, definitely B moved down. So downward, and it was hanging vertically downward. So for B, it is simply here, it is going to be how much? It was zero point 0.6. Zero point 0.6 meter was height. Okay. Not this one, 0.6. It was straight away, not according to the triangle. We will write here. It is just height of A. B. Height of B is equal to zero point 0.6. Well, now we are going to apply the concept they have told. They have told us to apply the energy equation. So let us write energy equation. So energy equation, so work done by driving force minus work done by resistance force is equal to change in GPE, as there are two particles. So GPE of A plus change in GPE of B, gravitational potential energy of B, plus change in kinetic energy of particle A plus change in kinetic energy of particle B. Well, now we will substitute the values. First of all, let us see whether there is any driving force or not. If we consider the system, look at it is actually they are connected with each other through the string in between them was working as driving force and resistance force. So as there is no other external force, driving force is zero. Remember, if there is no external force acting on the particles, then driving force is zero, so work is also zero. Now resistance force, for particle B there is no resistance force. For particle B, it was just hanging, so there is no resistance to motion. But for particle A, as it was lying on a rough surface, so definitely there is a resistance, I mean frictional force, which is external force. So our frictional force is Fr into S. We know work is equal to force into displacement. And change in GPE, so change in GPE is mgh of A plus mgh of B plus kinetic energy. We know the formula is half of mv square of A plus half of mass of A into final velocity of particle b square. Now we will apply the values. What are the values we do have? Look at this. The first one is frictional force. Frictional force is mu r. We have written mu was zero point 0.4, and our frictional force was 60 Newton. I can show from the previous page. And s, actually the each of the particle moved 6 meter, so point 0.6 is equal to mass of particle A is 0.65 and acceleration due to gravity is 10. Then h, we have already written the particle A was moving downward. How long? 0.6 meter. It was moving downward. Okay. So for downward, fine. Actually, height means it's difference between the initial and final height. Final height is 0.6 meter. So initial height was higher. Actually, it was moving downward. So it should be negative. It should be negative. So negative symbol can be written over here. If we use here negative symbol, negative, then by erasing this I can write it more clearly. Let me erase this. So it is equal to minus 0.65 into 10. This is for particle, sorry, this is for particle A, not particle B. I made a mistake actually. 0.65. So for particle A, it was already we have found it was how much? 3 over 13. For particle A, height was 3 over 13 and it was moving up. Remember, if B was sliding, moving down, so A was sliding up. That's why it is final height is more. That's why it will be positive. It is how much? 3 over 13. 3 over 13. Let me show you again. It was 3 over 13. Then for mass of particle plus mass of particle B is 12 and acceleration due to gravity is 10. Then height must be negative. Okay, negative how much? Let us write here negative how much? As I have told, B was moving downward, that's why the final height is getting less, so it is negative. 0 minus 0.6 is minus 0.6, minus 0.6. Well, after that, plus half of mass of particle A is 6.5 and final velocity is to be obtained. Initial velocity is 0. That's why there is no necessity of subtraction. Plus half of mass of particle B was 12 and velocity was same. Actually, initial was 0, final was v square. Final was v. Then if we simplify this, it is going to be 4 6 24, 24 6 are 40, so 14.4. It is negative 14.4. Negative symbol should not be ignored. It is negative 14.4 is equal to here 65. If 65 is divided by 3, that is 5. So 5 3s are 15. It is going to be 15 plus, for the second case it is 120, and if we this is actually multiplication. Look, if we multiply one, it is 72 actually. 120 into 0.6, that is 72. Then plus, but it should not be addition, it is going to be subtraction. Let us use subtraction symbol because it was a negative symbol, height was negative, so it is negative 72 plus here 6.5 and 12, it is 18.5. So half of 18.5, 18.5 over 2, then v square. Well, so if we calculate this, 15 is going to from 72. If we subtract 15, it is 57. So 57 is negative, it is going to be positive. So let us write 57 minus 14.4. Okay, is equal to, it is going to be 9.25, isn't it? 9.25 v square. So finally our v is going to be, sorry, our v is going to be, or v is equal to, from 57 if we subtract 14.4, it is going to be 34, isn't it? 32.6, 32.6, and then it is going to be 9.25, 9.25. Hence our velocity is going to be, our velocity is going to be v is equal to, hence v is equal to, our v is, let us do this calculation, 32.6 over 9.25. Using our calculator we will get 32.6. Sorry, we made a mistake, it's not 32, it will be 42.6. Okay, so let me write here 4 instead of 3, it is 42.6. Okay, so we will divide square root of 42, 426, 925. So 426 square root of 4, 146, so it is 2.146. If we round it up to three significant figures, it is going to be 2.15 meter per second. So this is what the final velocity of B should be, and that's all about the answer to the second part of the question. And I tried my level best to explain every tiny part, and I believe that if you have been attentive to the fact, then you have understood. May Allah bless us all with the beneficial knowledge. Allah Hafiz. Let me show the second part again. Yes, this is what the second part. Simply, we have applied the work energy equation, and for the first part, we have applied the method of, there are two cases. One is the when a particle is held equilibrium. There are two cases. One is the particle may slide down, was about to slide down, or was about to move back, I mean slide up. In these two cases, two values have been obtained for B, and if the value of B, I mean mass of B is more than zero point 0.1, then it would, less than zero point 0.1, then it would slide up. If the mass of particle B is more than 4.9, then it will slide down, I mean move down. That's all about these two solutions. Fi amanillah.